So for practice 12, we're going to continue looking at recurrent neural networks, particularly long short-term memory networks, and their ability to generate time series by training them to predict the next point in a time series. This is broken up into three hypotheses here, and then an initial section for setting up things. So normal standard section here where you import your libraries. There's also a function to sequence that we'll use to convert this our training data, which is one long sequence, into a number of different training sequences here. And we give it the sequence size, and it creates a set of sequences that size. So our first hypothesis is that longer training sequences give better predictions. The idea is if a network is trained on only like the last, so if we're looking at a sequence of numbers, if you see three numbers in the sequence and you're trying to predict the fourth number, that's a little harder, where if you were to see like 10 numbers in a sequence and then predict the 11th, hopefully you have a little better idea of what the next number is. So we start by generating, we're just working with simple things. We're working with a sine wave here. So we have three different kinds of sine waves in this initial one with a shorter frequency, one with a longer frequency, and one which mixes sine waves up and gives this more complex pattern. So these are called the short sine, long sine, and complex sine samples that you'll be working with. And then here's where you decide which of these samples you want to try, and you might want to test your hypothesis on more than one of these. So again, you can, if you want to do the short sine sequences, you could uncomment that one out and comment this one out. So whichever one you want. So sine sample, set that equal to whichever one of these three you want to try in this run. This then sets up the training and testing data for us to use. Oops, I forgot to run this up here also. Okay, so now I'm running the things in order. So initially we'll have 800 sequences that we'll use for training, and then 200 sequences that we have for testing. In this case, the testing and training aren't that relevant because this is a repetitive wave. So we will see the training data looks almost exactly like, the testing data looks almost exactly like the training data. So that's not all that important, but we left that in there. So again, here's where we're going to set up our sequence. We have one long sequence here of, let's say, numbers. This isn't a sine wave. This is just numbers growing and things. And then the idea is that you can present three numbers to the network and have it predict the fourth in each case. Or you could predict more. Here we're presenting five numbers and having it predict the next one. And it's particularly with a sine wave that goes up and down and up and down. Seeing more numbers helps with the predictions. So here's where you set the sequence size, and this is where you can change this. So if we want to do this where we only see five numbers, I would change this value to 5 here. And I would then set up my training sequence, and this is where we call the toSequence function that was defined in section 0 above. So this sets up our sequences. We have 794 sequences, each 5 long, and the one output. And again, what we're looking at, we're going to present it with 5 numbers and have it predict the 6th number in our sequence. Now we're going to build the network. And again, in this model, we generally want to decide on one network here and keep it fixed, and we're just going to check on performance based on the sequence size. This is the one parameter you should change and do this a couple times. So again, our hypothesis is as you change the sequence size, do you get better results here? And so you can try this on different input patterns here and see if hopefully your hypothesis holds on different input patterns. But again, our goal is to keep most of the other things the same. So once you decide on a network and a training idea, keep that the same for each. So we'll do that. We've got this set up, and then we're going to train our network. And again, decide on a fixed number. You can probably leave this set at 40 epochs and work through. So this should train. It should train relatively fast because again, this is a relatively simple network. We have some learning rate reduction set at here. You can leave those. Again, whatever you choose, you should probably leave stable throughout all your tests in this for this hypothesis. And then once we get that training done, we want to try to generate some longer networks or some longer predictions. So this generates a prediction and this plots it out. So the idea is you can see this sine wave going up and down, up and down. So the dotted line is the original data, and then the green line is its predictions going forward here. And it looks like it's doing an excellent job for this. So you can try that out, and then you can try out other things. But you know, that's the short sine wave is probably the easiest one because it changes on a regular basis and it's easy to follow. This longer sine wave is going to be a little harder to predict, and then this complex one is the hardest of all. So again, if I wanted to see something more challenging, I could also. So the next thing I could say do is this. Well, what if I dropped the number of, so it seemed like it predicted it really well. What if I dropped this down even further and ran that test? So here's my test with only a look ahead of 2. And again, this was the original data that's being fed in, and here's my predictions, and it doesn't do a very good job of predicting it. So again, try out different things, see if you can show that hypothesis and describe what tests you ran and how that worked. So that's the first hypothesis, is to work on the length of the training data here. Longer training sequences give better predictions. So the next hypothesis is are long short-term networks really better than simple recurrent networks? So similar idea here. Again, you have to run section 0 stuff before here. But the idea is that we've got our network set up. We can select our training data here, and again, you can try the different simple networks, simple sequences, and then the more complex sequences. These are our 3 sequences, and you can choose which one you want by commenting out the right one here. And then we set up our training data, and we're going to leave, in this time, we're going to leave the sequence size fixed at some value, set up the training data, and then we're going to define 2 networks, a long short-term network, a long short-term memory network, and a recurrent network. And we're going to try to set these structures up basically the same. So they have the same number of layers with the same number of nodes in each layer, but simply alternate. These layers are long short-term memory layers, and these are simple recurrent network layers. So again, you're free to modify this, but again, we want modify them both equally so that we have a good comparison between these, so that both networks are similar in structure. Then we'll do our training again, and again, you probably want to just leave the training the same here. Here we're just training for 40 epochs. And again, we have to train both networks because we have 2 separate networks. So there's one training here for the long short-term memory network and another one for the recurrent neural network. So train those both. So once the training is done, we're going to generate our sequences here and compare them. Now, one thing you'll see here is that there isn't a clear numeric way of comparing these sequences and which one generates the best sequence. So we want you to use your own just visual look at these sequences and see we're not doing what we'd call a quantitative comparison. We're not doing some calculation. We want to just have you look at the quality of each one and see how simple it is. And in this case, so this is, let's see, which one is this? This is a long short-term memory network. And again, this was our original signal that we fed in. Seems fine. And the generation looks like it continues that quite well. And this was our recurrent neural network, and that seems to work fine too and continue well. So it seems like our hypothesis that long short-term memory networks are better than recurrent networks is not true yet, because they're both doing equally well. But you should try this with some of the more challenging networks. So change the data that we're sending in here and try these other sequences and see if this is true for all the sequences. And you want to find a case where one has trouble and the other one succeeds for that. So if changing these networks to more complex networks doesn't help, you can also try to make some other things a little harder. You could reduce the sequence size a little bit and see if that would also help for this. Or reduce the number of nodes here, one of those. But again, what you want to do is find some situation where the two networks are not exactly the same, performs differently. But I think you can reach that simply by trying out some of these different networks. The short sign sequence is the easiest one for both of them, remember. The longer one is a little harder, and you'd think long short-term memory networks, which holds more state information, would be better at this. And then the complex network is probably the hardest of those. And so that would be a challenge, might be, for each one. So certainly try that first and see if you see some difference in performance for that. And then describe your results, what you tried, and how you interpret those results. Answer these up here. So, okay, the last hypothesis you've got to try here is can a long short-term memory network differentiate between different sign periods? Can it understand the data differently? So far we've been training the network on a single sine wave, and you'd like a network to be able to learn different networks. So here we actually have three different sine waves: a medium sample, a short sample, medium sample, and long sine sample, and that we're just varying the frequencies. So we have a short, fast frequency here, we have a medium one, and a long one here now. And we're going to train our network on all three. So we're going to actually combine all these sequences together and then break them up. And so now we end up with over 2,000 training sequences, and we're using a large sequence size of 100 so that it will see lots of points along this period. And now we're going to actually train our network here. And then we'll generate our sequences. So this training is going to take a lot longer. It's a lot more data, and we're going to train it for 100 epochs. This training will take a long time. So let this run. Here right now it's taking about 10 seconds each. It'll take, and we're doing 100 times. And then you'll run this data where we'll generate the network, and you can kind of see. So we'll feed in. The first one will be a prediction for a different inputs, short, medium, and long sine waves, and you'll see how it predicts, and you can describe that quantitatively. So, I mean qualitatively here. Okay, so that's your investigation in long short-term networks for this.